Consider the following problem. Given a directed graph and a target node 0, is this target node reachable from some input node, say 3? Now, so there are two approaches. There's a global approach. You can, for instance, compute the transitive closure and then just look up the answer. Or you can do it locally. You start by 3 and you only traverse nodes that are really presumably on the path from 3 to 0. Thus avoiding seeing any other unnecessary nodes. So this problem can also be stated in a less obvious manner. So for instance, given this Boolean program here with 3 Boolean inputs, we want to know, does it terminate when you feed into it 1, 1, 0, for instance? This is actually exactly the same problem as the one before. It's just stated in a different way. Okay? Or I can even state it in a even less obvious way. I can ask you, what is the Boolean value of this expression here, which is to be read as take the least function f, which takes some input x, this is supposed to be a triple in this case, and returns some expression recursively depending on f and of course depending on x. And you take this least function f and you apply it to some inputs I0, 1 and 2. So the question is, does this evaluate to true or not for given inputs? Again, so this is just a reformulation of this problem up there. The difference here is you might suggest a different approach, saying, well, this function lives in a lattice, which is basically a function lattice, with pointwise order, and in this function I can compute the least fixed point. In this lattice, I can compute the least fixed point by fixed point iteration, which amounts to just constructing this function, and then we apply this function to the input values and see if the result is true or false. Now this is actually global because this computes the value of this function on all arguments rather than just on the necessary ones. So what this talk is about is how to compute such values locally, meaning that we avoid the computation of unnecessary values when evaluating fixed point expressions in higher order lattices.